Hi there, in this in this video, we're going to be dividing fractions. So let's open it up and get started. In the first example, we have a problem, a division type problem involving fractions, 2 1/3 divided by 2/5. The first step we want to do when we're dividing fractions is to change all our mixed numbers into improper fractions. All right, so this is an example of a mixed number. I want to make that improper before I even start the problem. The other thing you want to change in a division problem are your whole numbers. If you just have a plain old 2, you want to go ahead and write that also as a fraction before you get started with the division. I don't have one like that, but when we get over here, I'll show you what I mean. All right, so the first step is to change our mixed numbers into improper fractions. I do that by using around the world or Texas. I'm going to multiply first. 3 times 2 is 6, and then add the 1 to get 7. So I'm changing that mixed number into 7 over 3. My second step is to keep the first fraction the same. So after I've changed everything and made it a fraction, made it an improper fraction, I'm going to rewrite the division problem by keeping the first fraction the same, so 7/3. Then I'm going to change the division sign into a multiplication sign. So before I change this to 7/3, I'm keeping that part 7/3. I'm changing division now into subtraction. Not subtraction, multiplication. All right, and then the last step, or the fourth step, is then I'm going to flip the second fraction, and what I'm doing actually is finding the reciprocal. All right, so my second fraction was 2/5. If I flip that over, I get 5 over 2. So 5 over 2 is the reciprocal of 2 over 5. And so my new problem looks like this, 7/3 times 5 over 2, which I know how to do because I've already learned how to multiply fractions. So let's just kind of go back over what we just did. We started with this, 2 1/3. We first made this an improper fraction and got 7/3. We changed division to multiplication, and then we flipped the second fraction, 2 over 5, and made it 5 over 2. So we keep, change, flip, and now the last step is just to multiply. So 7 times 5, 35. 3 times 2 is 6. And then, as always with fractions, you don't want to leave an improper fraction or an unsimplified fraction, so we need to go ahead and change that back into a mixed number. I'm going to do that using Tybo, top in, bottom out. 6 will go into 35 5 times. When I subtract 30, I have a remainder of 5. So this 5 is my whole number. This 5, the remainder, is my numerator, and then my denominator is still a 6. 5 6 is not able to simplify, so this is my final answer, 5 and 5 6. All right, keep, change, flip. There's a great little kind of music video that goes with this if you want to look it up. It'll help you remember what to do in dividing fractions. Now, some of you may be able to remember cross-reducing. If this confuses you, this next part, you don't have to use cross-reducing. It's just kind of a way to simplify before you get to larger numbers at the end. It's a great little tip once you understand how to use it. But again, right now we're concentrating on dividing fractions. So if you don't get this part, then feel free to not use it. But I do want you to at least see it. Cross-reducing allows you to simplify both fractions in step 4 before you multiply them together. This is done before multiplying. It's simplifying before you multiply. And the way you cross reduce is always diagonally, not across, not horizontally. All right, so this would be like, okay, if I had 4 instead of 4 over 9, what if I had 4 over 8? Could I simplify those two numbers? Well, yeah, these are both divisible by 4, right? So if I divide 4 by 4, I get 1, and if I divide 8 by 4, I get 2. So what I do is I go ahead and simplify this. And then I'm going to multiply using the new numbers. So 1 times 1 is 1. 9 times 2, this is now a 2, is 18. All right, so this would be my final answer, and it's already simplified, so I don't have to do that step. Now, what would have happened if I hadn't done that? I would have multiplied 4 times 1 and gotten 4. 9 times 8 would have given me 72. But here, I have a fraction that has to be simplified. And maybe I don't know that I can divide by 4, so I divide by 2. And I get 2 over 36. And then I can keep going, divide by 2. And I get 1 over 18. Again, you're going to get the same answer either way you do it. This just allows you to simplify before these numbers get really big. So it's kind of just a shortcut if you understand it. If it's not something you want to use, you're not required to use it. All right, again, our focus is on dividing, so we're going to concentrate mainly on that now. I have 1/3 divided by 5. I need to change mixed numbers to improper. In this one, I don't have any, but I do have a whole number. So I want to make sure my whole numbers are fractions as well. In order to change 5 into a fraction, I'm just going to write it as over 1, like that, 5 over 1. Now, keep, change, flip is what you need to remember for dividing fractions. So I keep the 1/3, I change division to multiplication, and I flip 5 over 1. Just turn over the numbers to 1 over 5. All right, and then you just multiply. 1 times 1 is 1, 3 times 5 is 15. Number 2. Now this one has negatives. You're going to see that it really doesn't make a big difference, but we do have to remember our rules for dividing and multiplying positive and negative numbers, and I'll show you that in just a minute. But to start it, you do the same thing. First thing we do is change any mixed numbers into improper fractions. I have one here, so I need to use around the world. I'm going to keep the negative 1/4 for now, and I'm going to keep this as division until I get rid of my mixed number. So 8 times 1 is 8. Plus 1 is 9 over 8. And then because this is negative, I need to make my fraction negative. So negative 9/8. All that changed was instead of a negative mixed number, I now have a negative improper fraction. Once it's like this, I can use keep, change, flip. So keep the negative 1/4. Change division to multiplication. Flip means switch the numbers. So this becomes 8 over 9. Now, what do you do with that negative? It just stays on top because we like it there. All right, it's not attached to the 9. We can kind of move it around wherever we like it. We like it on top. All right, so now if I go ahead and multiply negative 1 times negative 8, I need to remember the rules. A negative times a negative is what? Think of Sleeping Man. Negative times negative is positive. All right, so this becomes a positive 8 over 4 times 9 is 36. Can you simplify it? Yes, they're both divisible by 4. So this becomes 2 over 9. All right, so this is one of those places where cross-reducing would have worked, right? We had this 1/4 and negative 8/9. If I had noticed that 8 and 4, I'm able to simplify this, then I could have done that first. I know that 4 divided by 4 is 1, and I know that 8 divided by 4 is 2. So now I have negative 1 times negative 2, which is positive 2. 1 times 9 is 9. Did I get the same answer? Yes. Did I just simplify before this step? Yes. Okay. But again, if that confuses you, don't use it. Sorry. We'll make them look like a man there. All right. Number 3. First step, change them to improper fractions. 4 times 2 is 8 plus 1, 9 over 4. Keep the division for now. 2 times 1 is 2 plus 1 is 3 over 2. I'm going to make sure that I keep it negative because my next number was negative. Rewrite it as a multiplication problem using keep, change, and flip. Keep the 9/4, change to multiply. Flip the 3 and the 2 to 2 over 3. But remember, the negative is going to stay in the numerator just because I like it there. All right, now multiply. 9 times negative 2 is negative 18. 4 times 3 is 12. All right, this is improper, so I want to go ahead and divide top and bottom out. 12 will go into 18 one time with a remainder of 6. This becomes 1 as my whole number, 6 is my numerator, 12 is my denominator. Now, because this is negative, my mixed number is negative as well. So make sure you can see that. That's a negative 1 and 6/12. This is still not simplified. These are both divisible by 6. So now I have a negative, keep the negative, don't lose it, 1, keep the 1, and then this simplifies to 1/2. So here's my answer here. Now again, I could have cross-reduced before I got to that step. If you do that, then back at this step here, I'm going to show you on another piece of paper. If you have 9/4 times negative 2/3, then right here I could have seen diagonally, oh, you know what? Both of these numbers are divisible by 2. 2 divided by 2, that's negative 1. I'm going to keep the negative. 4 divided by 2 is 2. I can also cross-reduce this way. Both of these numbers are divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So now I would multiply using these new numbers. 3 times negative 1, negative 3. 2 times 1 is 2. That's improper, so I still have to do this part. I can't skip this step. Top in, bottom out. 3 will go into 2 once. When I subtract, I get 1. So it's still negative because of this negative here. Don't lose that. It went 1 time. My remainder was 1, and my denominator was still 2. So my final answer is negative 1.5, which is the same thing I got here. I just did it a little with just like one less step because I reduced first. Again, do the method you prefer. All right, and then there's one other type of division problem I want you to see. It's called a complex fraction, and it looks like this, which can be a little scary looking. But what we need to remember is that that fraction bar is just another way to write division, kind of like we use the dot for multiplication, or we could use the X, or we could use parentheses to mean multiplication. That fraction bar is really just telling me to divide these two things. It's called a complex fraction, and it looks complex, but that's because it's a fraction within a fraction. So complex fractions are fractions within fractions, and all you need to do is rewrite them as a division problem first. Then you're just right back where you started. So the first thing I'm going to do is take the top part, 1 1/3. That fraction bar means divide by what? 1/4, the bottom part, the denominator. Okay, and then I'm right back where I started, so it's really not that complex, is it? I'm going to start with making improper fractions. 3 times 1 is 3, plus 1 is 4 over 3. Keep that. Change to what? Multiply. Flip to the reciprocal, 4 over 1. Then multiply across. 4 times 4 is 16. 3 times 1 is 3. Change it back into a mixed number, typo it. 3 will go into 16. 5 times 3 is 15. Subtract and get 1. So my answer is 5 is my whole number, 1 is my numerator, my denominator is still 3. That is simplified, so 5 1/3. So he would have guessed that this big thing here would be this. Not me, but I don't have to because I know how to do it. All right, last example. This is a complex fraction because there's a fraction inside the fraction. So all we have to remember is that fraction bar also means what? Divide. So I'm going to rewrite this as 18, the top part, divide it by what? The bottom part, 3/4. And now I can ignore this and just work this problem out. Change your whole numbers into fractions by rewriting them as 18 over what? 1. Okay, so keeping that 18 over 1, changing, keep, change, and then what? Flip to the, what's that called? A reciprocal. All right, now I'm going to multiply. 18 times 4, I don't know what that is. 8 times 4 is 32, carry your 3. 4 times 1 is 4, plus 3 is 7. So that gives me 72 over 3. That is not simplified. I need to typo it. So 3 into 72. 3 will go into 7 2 times. That's 6. When I subtract, I get 1. Bring down the 2. 3 will go into 12 4 times. And this time there's no remainder. So what does that mean? It means my answer is just 24. Now again, could I have reduced this before I got to this step? Yes. I'll show you over here. So let's say you had 18 over 1 times 4 over 3. If I want to cross reduce, I can notice that 18 and 3 are both divisible by 3. 3 divided by 3 is 1. 18 divided by 3 is 6. So when I multiply, 6 times 4 is 24. 1 times 1 is 1. And then this is still equal to what? Just 24. It's 24 wholes. Okay, same answer. All right, so one more time, dividing fractions. Ain't no lie. Flip the second one and multiply. Another way to remember that. Or keep, change, flip. Change your mixed numbers and whole numbers into fractions, improper fractions first before you keep, change, flip. Make sure you pay attention to negative signs. And then one more time, complex fractions, they look scary, but they're not. All you have to do is rewrite them as division first, and then you're good. All right, see you soon.